Thank you. So, hello everyone. Thanks a lot for attention to my topic. Today I will talk about EPAM experience in migration a big monolith to serverless architecture based on AWS Lambda from developer perspective. It will be not a lecture about how to do something right. It mostly be like another one project story with some lessons learned. Shortly about me, I wasn't always bold. And my name is Dmitry Skirnyakov. I am software engineer at EPAM, and I'm writing on Java and Python. I have 3 years experience in development with serverless approaches, and I'm really encouraged with that. Let's look into our small agenda. Before telling our story about migration, I will say just a few words about serverless definition. So if somebody missed all today's topics about serverless, we all will be on the same page. After that, I will tell you about the challenges that our team met during this migration. I split them into some checkpoints that our team finished, and we will review the solution, what we found, and that help us. Also, we will imagine how these solutions, how these challenges could be overcome today. So let's start. Serverless could be defined as a cloud computing execution model where the cloud provider takes all the responsibility for provisioning, maintaining, load balancing, and managing the computer resources for you or servers. And serverless applications runs into some kind of event-driven and ephemeral containers which may last only for one request. Pricing model is based on the use capacity, for example, on the number of executions and execution time instead of pre-provisioned capacity. It means that you will not be paid for unused resources. Sounds great, doesn't it? That's why we were so attracted by this technology in 2016. Let me introduce the legacy application with which we dealt. EPAM Cloud. It is internal project of EPAM created in 2012. It is a hybrid cloud that operates the main part of EPAM virtual infrastructure, and it has a lot of functionality related to provisioning, maintaining, billing, and monitoring resources in different cloud providers, from public, such as AWS, Azure, and Google Cloud Platform, to private, such OpenStack and VMware. But more interesting for us is the architecture. Atop of this architecture, firstly, it is a classic monolith copied into several nodes. And atop of this architecture, we have one node that takes the request dispatch role. It processes all requests received by RPC API and handles some of them, for example, like describing current state of infrastructure, and pass other requests to orchestrators that located on the cloud provider level. For storage, we are using one MongoDB replica set that allowed us to have a separate database for each orchestrator instance. Each public cloud and each private data center has their own copy of orchestrator for supporting independent management and reducing the delay between initialization and performing the operations. For connection between request dispatcher and independent nodes, we are using AMQP that allowed us to decouple the components of our system and save all requests in cases when some orchestrator node is down. In 2016, was decided to turn this big project into a product because a lot of clients asked about such orchestrator for their clouds, but with some small customization. Unfortunately, it wasn't available to be done quickly. There are two main reasons why. At first, it was monolith. The project repository contained more than 1 million code lines, and it was really hard to understand what's going in these thousands of classes. And also some change in legacy model or adding a new broken model could break all the application. And that's not fine. Finally, this application was very coupled with EPAM ecosystem, with internal services, internal infrastructure, and internal business model. Then our young team that consisted only for 5 people received the task from the scope of productization. Take the functionality related to AWS Cloud, decouple it from EPAM ecosystem, and migrate to serverless in the 3 months. Serverless was chosen because it is really easy to extend architecture with almost zero initial cost. And let's review what our team had at the beginning. We had only 5 developers, 1 senior developer from legacy project, and 4 junior developers that just got on production. We had 1 million code lines and 3 months to migrate some of them. Looks like a great challenge for such a young team, and we accepted it. When we started to design what we should do, we found that the most part of our knowledge is useless. We had to change all the technologies that we used previously to completely new ecosystem, but in our minds, everything looked understandable. At first, we changed MongoDB to DynamoDB because it is also NoSQL that should mean they are almost the same. Why not? After that, we changed Tomcat and Nginx to AWS Lambda for holding our code and API Gateway for routing HTTP requests to Lambda. And we hope that everything will be OK. If we simplify the scheme, we will receive such architecture. We spent a lot of time to understand how these services should interact with each other. And I guess it is the main reason why we missed our initial deadline, as expected. The first thing that you should keep in mind when you start to develop with serverless approaches, it is not only about function as a service approach. Mostly it is about different mindset. You should think stateless. The most part of process in your application could be presented in some kind of pipelines with events and functions, and could be implemented with cloud services. And if you would like to be familiar with these services, you could find a lot of trainings and courses and make these services closer to you. 3 years ago, we had not such ability, and you could see this on this simple statistic from Google. By the way, about useless knowledge. The first Lambda feature that affected us a lot was a cold start. It's a case when your request initializes a new container and it takes time. You should keep it in mind because it affects your end user. And the first thing that we had to do for reducing this time is to abandon Spring due to a long time of context initialization. It means that such great features like Spring Cloud, Spring Boot, Spring Data were unavailable for us. We rejected the decision to create some kind of our own context. And after some time without habitable Spring Bean factory, our code turned into a true monster. And we had that. It is not the worst example. Sometimes it takes more than 200 of code lines to create all objects required to our Lambda. I will agree if you will say that it looks ugly. And then we understood that we should find the solution that would help us with dependency injection, but will not affect the cold start time. And we opened the Dagger framework. Instead of detecting dependencies and creating all required objects during the runtime, how Spring does it, Dagger generates tons of object factories during code compilation. Yes, it increased the time of artifacts preparation, but saved such precious seconds during cold start. And now you could use Spring. This model, Spring Cloud Function, enables such features as Spring Boot for you and for such serverless providers as AWS Lambda. You can find more details about its functionality on the official website. The next challenge we met was API design. One of my favorite questions to students during the interviews is about functionality delivery. How to deliver your code that is so cool and so clean to your end customer. In the modern world, it is API. And when we started to split our functionality to lambdas, we followed one main principle. It was single responsibility. One lambda should perform only one small piece of functionality, or only one function. And how we mapped it on our functionality. One lambda for starting the instance, one lambda for stopping the instance, and lambda for rebooting the instance. And also, we mapped it on our API gateway endpoints. It doesn't look rational. There is one great pattern that could help you with migration your legacy applications to some kind of new architecture or new version of your applications. It is STRANGLER. Assume that you have legacy application that you would like to migrate to some kind, for example, new architecture. First thing that you should do is to create Facade API and redirect all your traffic to this API. Users will interact with Facade, and any details about its implementation will be not important for them. After creating this facade, you will be able to add your new application with cooler and newer architecture and redirect some requests from facade API to your new application. User experience for both parts of your application will be the same because he interacts not directly with your application, but with facade API. And AWS has a very powerful service for that. Of course, it is API Gateway. API Gateway has a lot of different functionality, but I would like to highlight two main features that could help you with implementation of that pattern. At first, it is support of Open API or Swagger configuration. You can write Swagger configuration for your already existing API and use it for deploying your already existing API as good as for creating API gateway resources. And if you will spend more time with Swagger configuration and you will use the Swagger extensions provided by AWS, you will be able to automatically route all requests from API gateway to your API. The second feature is the support of a wide range of targets. For example, if you write the serverless applications, then API gateway could trigger your lambdas. And if you write more canonical applications based on instances and containers, you could use EC2 instance, application load balancer, or another available AWS service as a target. Finally, you could use any publicly available HTTP endpoint as a target for AWS resource. It means that you could proxy your requests to almost any available service in your virtual private cloud. With the increasing lambdas count, we faced with such difficult process as deployment package preparation. It doesn't mean how good you split your functionality by lambdas and how many lambdas do you have. You will always have the common models that should be shared with each component of your system. And when we started to write lambdas with shared models, we had a very primitive process. For example, if somebody changed the common model, the first thing that he had to do, notify us developers. Hey guys, I just changed the logic of DynamoDB interactions, please update your lambdas. And when we wanted to update our lambdas, we came to the most experienced DevOps engineer from legacy project and asked him about, hi, could you update my lambda? We delivered him a fat jar with all required dependencies, and he manually went to AWS console and for updating our lambda code and for configuration all required integrations with other services. Here we can find a very huge breach in our processes, lack of automation. Initially it worked for us, but when lambdas count came to tens, this guy started to reject all our requests because he was overloaded with this monkey job. Then we understood that we should automate all these things and all this job. Everybody who started serverless development in 2016 or 2017 used this phrase for experience describing. There were no Terraform, CloudFormation, or another good tool in such state as we have it now. And due to the absence of good tools for serverless CI/CD, we decided to create our own. Then we started the development of our own deployment tool based on Python and Boto3. We presented such great processes as artifacts preparation and deployment based on these artifacts. And as a result, this tool evolved into a separate project. And we called it SYNDICATE, deployment tool for AWS serverless applications. And it is available on GitHub. I could talk a long time about its features, advantages, and disadvantages, but you could find all required information on the GitHub. And now you could create your own CI/CD with your lovely tools. Just for AWS, we have Terraform, CloudFormation, Serverless Framework, Serverless Application Model, Cloud Developer Kit, and a bunch of other services that integrated with AWS Serverless services. Now we have problem of choice instead of lack of possibilities. And also you could use SYNDICATE. We already know about such Lambda feature like cold start, but Lambda has more features related to physical limits. For example, the first physical limit that we met was invocation timeout. Long-term tasks almost not supported by AWS Lambda because it has a very small function invocation timeout. In 2016, it was only 5 minutes. Recently, it was changed to 15 minutes, but it's not allowed us to use Lambda for function with a big amount of work. And when we ran into this issue during the migration of functionality with a big amount of long-term tasks, we didn't find any better solution than to add server instance with part of monolith migrated as is to our serverless architecture. And for supporting this functionality completely as is, we added MongoDB instance. It was the time when we started to call our architecture serverless. Now, for these purposes, you could use such services as Fargate and step function. The first one is a container level analog for AWS Lambda. Fargate could be helpful if you have long-term tasks or you should have access to your images, for example, because AWS Fargate integrated with ECS. It means that you could prepare your own Docker image, upload it to ECR, and use them for tasks created in Fargate. The second service is step function. It consolidates all AWS serverless services into some kind of workflows based on state machines. That means that you could present all your workflows with simple diagram and monitor all your workflows directly within this service. And it is also serverless. You will pay only for count of execution, and you shouldn't support any servers for this service. The almost last challenge, big challenge that our team met was connection to the private services located not in our virtual private cloud. For our case, it was connection to private agent located in OpenStack private cloud. Due to lack of knowledge in networking and any abilities to establish connection between resources located in our virtual private cloud and resources located in somewhere else, we didn't find better solutions than to add RabbitMQ server on another EC2 instance. It allowed us to decouple the components of our system. It allowed us to decouple our public part and our private part, and allowed us to use functionality from private agent. But it is still a primitive and not serverless approach. Last year, at the reInvent 2018, AWS Transit Gateway Service were released, and it radically simplified the network configuration in AWS. You should use only one connection between your central gateway and the point that you would like to attach. It could be another virtual private cloud from another account. It could be one premises data center, or it could be your remote office connected via Direct Connect service. It acts like a hub and route all traffic between all nodes of this great big network. And also, it could be named serverless because you shouldn't maintain the servers for this, and you will pay only for traffic. Now, the team that are working on this solution consists of 15 people, including quality assurance specialists and DevOps engineers. We successfully migrated all required functionality and performed a lot of demos to our customers, and they started negotiations for future cooperation. But the most valuable for us was this. For this architecture, we went about a year and a half. During this period, we made a lot of different decisions based on our knowledge and our experience. And some of them, or maybe all of them, could be criticized. And I'm sure that in some cases we could do better, really better. We can't call this architecture completely serverless, but we also can't call this architecture completely monolith. There is only one thing that I could say without any doubt about this architecture. It is our experience. The last thing that I really would like to show you, it is this slide. It is just a part of current state of AWS serverless landscape. There are a lot of services related to compute, storage, monitoring, security, and application management. And all these services could help you with writing your own serverless application. 3 years ago, just a few services were available for us. And we had to write our own bicycles. Please, stay tuned with the latest technologies and use the opportunities that they give to you. That's all from me. Thanks a lot for your attention. I am ready for your question or for maybe your experience and sharing your maybe knowledge about new services, approaches in serverless. Okay, so
I just want to ask, what Java versions did you use in the monolith, and did you migrate, or do you have some planning for migrate the new Java versions?
sorry, I can't hear your questions. Can you speak louder, please? It
Uh,
works very bad.
okay,
Oh,
so
great.
great. What Java versions did you use at the beginning of the project, and did you migrate it? And if now, do you have some plans and potential? Maybe you see problems with Java
Okay,
migrations.
okay. So at our monolith application, we are using Java 7, and due to some limits related to AWS Lambda runtimes, we are using Lambda 8 because we still not created our own custom runtime with latest Lambda, for example, with latest Java, for example, or Java 11 or Java 12. Unfortunately, it is still Java 8. And
And I don't know if AWS allows you to use, for example, Java 11 if you have another some business then you want to develop from scratch.
actually, it was, I guess, the main point for this migration, not to create a great product, but to try the serverless and the serverless on AWS and the serverless on AWS with Java. And it worked. Thanks a lot for your question. Maybe.
How much time it actually took to migrate the project to serverless or mixed serverless architecture?
Could you repeat, please? This microphone is
How much?
Maybe just.
How much time it actually took to migrate the project to the new architecture?
I will come to.
How much time it actually took to migrate to new architecture?
Okay, so absolutely we migrated just a part of the main functionality from the repository with more than 1 million code lines. But we migrated the main part that were requested by the customers, and for this process we spent almost a year and a half.
Oh, it's not so easy.
It's not so easy because we didn't know how to do such things. We hadn't such opportunities as we have now. For example, I said previously, we had to ride bicycles instead of writing functionality.
Do you have some disaster plan? Because you are not provider agnostic, and if AWS ban your account, what will you do in this case?
If I will better come to the left speaker. Could you repeat, please?
Okay.
I can't.
You are not provider agnostic because you use only AWS. Am I right?
Yes.
And do you have any disaster plan if AWS block your account or something like that?
At first, we comes with infrastructure as a code approach, and if AWS will block, okay, I understood your question. If our production account will be blocked, unfortunately, no, we hasn't any disaster plan related to that situation.
Because we had some negative case when Google blocked our account, and we should create some disaster plan, and if some of our account blocks, we just migrate to another cloud or something.
I guess for such situation, any support plans can help you with this. For example, EPAM has an AWS Enterprise Support Plan, and if some situation not covered by level 3 support comes to our engineers through the AWS Technical Account Manager. It is it is some technical, some management, and some I don't know, some relations specialist who dedicated for our company and who should be involved in all process related to AWS. So if such situation will be reproduced for us in AWS, this guy will inform us before performing any actions.
Okay, thank you.
Okay, thanks a lot for your attention.